The science of atomic radiation, atomic change, and nuclear fission was developed from 1895 to 1945. Much of it was done in the last 6 of those years. The reason for the abrupt skyrocket into its research was for World War II. The Germans began researching it in order to get a leg up in the war against the Allies. However, it wasn't the Germans who reached this milestone, but the Americans. The Americans, when hearing of this news, launched their own research into nuclear fission. The US then created a joint effort between the US, the UK, and Canada. This became known as the Manhattan Project. The Manhattan Project took over 130,000 people and $2 billion, which today would be the equivalent of $26 billion. The name Manhattan Project suggests it only took place in Manhattan, but that can't be further from the truth. Another location that the project took place was in Chicago. Chicago was instrumental to the Manhattan Project. It is where the famous physicist Enrico Fermi was able to create the world's first nuclear reactor. It was known as the Chicago Pile 1. Its creation was instrumental in the Manhattan Project. Successfully building it would mean that we would theoretically be able to create a sustaining nuclear reaction. Tests were done at the Metallurgical Laboratory in the University of Chicago. Enrico Fermi monitored the whole process. This was the first reactor, so it didn't have all the safety precautions such as a radiation shield or cooling system. This was in part to Enrico Fermi's insistence that his calculations were correct. Had he been wrong, there wouldn't be a University of Chicago. We were lucky that all went as planned, as the Atomic Energy Commission later pointed out that the gamble remained in conducting a possible catastrophic experiment in one of the most densely populated areas of the nation. If an explosion similar to the little boy, the bomb, which was dropped in Hiroshima, happened because Fermi was wrong, this would be its blast radius. As research began to escalate, the US was able to test the bombs in Los Alamos. It was a success. Many things resulted from the project, but the most memorable achievement was without a doubt the atomic bombs. The bombs were and are frightening pieces of technologies capable of leveling whole armies in seconds. Fortunately for the Allies, they were able to get a leg up because the Germans were fighting a war on two fronts, crippling their research. After defeating the Germans, the Americans set their sights on the Japanese. The Americans were then able to drop an atomic bomb on the Japanese, signaling the end of the war. The world has significantly changed since August 6, 1945. The dropping of the first bomb over the city of Hiroshima, its destructive capabilities were unparalleled. The bomb was meant to be the one to end the war, which it did, but that was only the beginning. After the end of World War II, two countries became the dominant players in the world, the United States and the Soviet Union. Out of the gate, the United States had the advantage. They had all the bombs. What were the Soviets going to do? Steal them? That's exactly what they did. Soviet spies and defectors were able to steal the plans for the bombs, and in 1949 were able to replicate it and make their own bombs. Soon, both countries feared each other as they both knew that any direct conflict would result in mutually assured destruction. This tension existed all throughout the Cold War. Both countries were very wary of each other, and as seen in the video, the US had tried to soothe the people, even though they knew that this would not work and they would surely perish. Because of this, the United States government tried to lock down its secrets. Their measures proved futile because the Soviets were able to replicate the results in 1949. There was a big controversy as to how work on nuclear energy should be handled. Many people, like Enrico Fermi, were adamant believers in that the military should take over research in order to stop the Soviets and anyone else from taking their secrets. Civilian scientists, however, disagreed because it would stop the exchange of information and also the development of using nuclear energy for a good purpose, such as for energy and electricity. Eventually, the civilians won out, and this created the Atomic Energy Commission. The Commission is the body responsible for the development of nuclear energy. They strive to achieve peaceful ways of using nuclear energy. Enrico Fermi, a pro-military proponent, was on that commission and was actually charged, along with others, with the task of creating a superweapon. He and others all said that such a weapon could not be justified on ethical grounds and strongly disapproved its creation. Fermi, however, helped with the task after President Truman okayed the project in order to hopefully prove that it was impossible to achieve such a superweapon. Today, we no longer live in fear, even though the possibility of it is still very much present. The University of Chicago's Bulletin of Atomic Scientists keeps the world up to date on the possibility of a nuclear bomb going on with its doomsday clock. The doomsday clock has been gauging the world on how hostile and how dangerous it is ever since the creation of atomic weapons. Nuclear power isn't all bad, though. The civilian scientists who were going against the military saw how we could harness nuclear power for good. Today, the world is reaping off the benefits of Fermi's experiments on the Chicago Pile 1. Nuclear energy provides the world with about 12% of its electricity. It produces large amounts of electricity efficiently. Here is a short clip that shows its usefulness to society.
As of today, the most pressing issue facing our world is the ubiquitous need for clean, safe, and efficient fuel sources. With increasing gasoline prices and dependence on foreign oil supply, scientists and engineers are exploring the potential of nuclear energy as an alternative to petroleum-based fuel and fuel-related products. Nuclear power aspires to provide an alternative to hydrocarbon resources by using the massive amounts of heat energy released when a uranium dioxide atom is split, a process known as nuclear fission. The heat from these reactions is then used to produce steam, which drives a turbine, generating electricity. A typical large nuclear power plant produces enough electricity to power more than 750,000 homes, but only about 20 metric tons of used uranium fuel waste each year, roughly equivalent to the cargo volume of a small truck. In terms of cost, nuclear power has a significantly lower production cost than coal and natural gas, helping to reduce the price of electricity for consumers. This includes the cost of operating and maintaining the plant, purchasing nuclear fuel, and managing the used fuel. Nuclear plants offer a clean solution to mitigate the environmental effects of today's energy-dependent society. Currently, the United States generates most of its electricity by burning fossil fuels, a process that produces sulfur dioxide, carbon dioxide, and nitrogen oxides. Nuclear power plants do not utilize combustive processes, and therefore do not produce combustion byproducts. The amount of carbon dioxide emissions they prevent is larger than those amounts of all other electricity sources combined. The volume of greenhouse gas emissions prevented by the integration of nuclear power plants is equivalent to taking nearly all passenger cars off America's roadways.
It is instrumental in the modern age as we try to get away from fossil fuels. However, as we know, nuclear power is as helpful as it is deadly.